Welcome and study with Tanzania Institute of Education.
Welcome to our chemistry period. My name is Madam Jennifer Kazilege. I'll be with you discussing our topic known as oxygen. Remember the previous discussion whereby we were discussing the laboratory preparation of oxygen. We said oxygen can be prepared in the laboratory by different methods. One of them, it is catalytic decomposition of hydrogen peroxide using manganese 4 oxide. Another method, it is thermodecomposition of potassium chlorate using manganese 4 oxide as well as a catalyst. And also we can prepare oxygen by heating compound rich in oxygen like mercury 2 oxide. But the common method for preparation of oxygen in the laboratory is catalytic decomposition of hydrogen peroxide. We call it catalytic decomposition of hydrogen peroxide. Why? Because we use a catalyst to speed up the rate of decomposition of hydrogen peroxide in order to obtain oxygen gas. And yes, last time we discussed about the setup for the diagram in preparation of oxygen gas using hydrogen peroxide. So today we are going to discuss about preparation of oxygen gas using potassium chlorate, though this method is not used in the lab because it involves heat, and when a reaction is involving heat, it may lead to fire accident in the laboratory. So the recommended method, it is only hydrogen peroxide, but it is allowed to understand how do we set the diagram during the preparation of oxygen gas when we are using potassium chlorate. And now consider how do we set the diagram. So preparation of oxygen gas, number 2, using manganese 4 oxide and potassium chlorate, using potassium chlorate with manganese 4 oxide, manganese 4 oxide. Remember, in the preparation of oxygen gas, there must be a catalyst. We talked about the definition of a catalyst. We said it is a chemical substance that will speed up the rate of decomposition of the reaction, but at the end of the reaction, it will remain unchanged. So manganese 4 oxide, it is a catalyst that is used in a laboratory preparation of oxygen gas. So now let us see what is happening during the decomposition of potassium chlorate. To decompose means to break down. Large compound is broken down into small compound or element. Now, this reaction cannot be successful if there's no heat. That is why it is called the thermodecomposition of potassium chlorate. Now, our chemicals, it is potassium chlorate. The chemicals that you're going to use, it is potassium chlorate. Potassium chlorate is written in this way, chlorate. The formula for potassium chlorate, it is KClO sub 3. This is potassium chlorate. And another chemical that you're going to have, it is manganese 4 oxide. Manganese 4 oxide. How is it written by using formula? You should know the word and the formula. This is MnO sub 2. That is manganese 4 oxide. Now let us see the setup, the diagram. How are we going to set the preparation in case we are in the lab? That is how we are going to set the diagram. We must have a boiling tube. Inside the boiling tube, we're going to add manganese 4 oxide and the potassium chlorate. Inside the boiling tube, we are going to add manganese 4 oxide and potassium chlorate, and We are going also to have a trough. We are going also to have a trough. That trough will be filled with water and beef shelf. A trough. This trough will be filled with water and the beehive shelf. There's a beehive shelf. This beehive shelf, it is where the delivery tube is inserted, and this is a trough containing water molecule, okay? Then over the trough, the beehive shelf, we are placing a gas jar. Over the beehive shelf, we are placing a gas jar. Why gas jar? Because it is used to collect the gas. And then this is the beehive shelf. The beehive shelf, inside the trough, there is water molecule. And then oxygen is collected here. This is oxygen gas. And this is a gas jar. It is gas jar. This is a trough. It is called a trough. And inside the trough, we must fill water, because you're going to see why do we collect oxygen by using water. So inside there is water molecules. We fill water. Within the boiling tube, we insert a delivery tube. We are going to insert a delivery tube. And then this is mixture of potassium chlorate. They are mixed together. Potassium chlorate and manganese 4 oxide. Chlorate plus manganese 4 oxide. Manganese 4 oxide. So when these two chemicals react, manganese 4 oxide will assist the decomposition, but don't forget the heat. Don't forget the heat, because if there's no heat, the reaction won't take place. So there is heat here. This one will assist the mixture to decompose. So potassium chlorate will decompose in the presence of manganese 4 oxide. And after decomposing, oxygen gas will be given out. What is the reaction involved? What is the reaction taking place in the boiling tube? This is called the boiling tube. Boiling tube. So the reaction is taking place within the boiling tube. This is the delivery tube to deliver the gas. Delivery tube. So inside the boiling tube, there is a reaction taking place between potassium chlorate and the manganese 4 oxide. Remember, manganese 4 oxide does not decompose, but it assists the decomposition of potassium chlorate in order to produce oxygen gas. So the reaction taking place, we have the reaction taking place within the boiling tube. Now, potassium chlorate will decompose. Potassium chlorate will decompose in the presence of manganese 4 oxide. So we have what we call word equation. We must know how to write a word equation, and it must be written in words. Therefore, this is potassium chlorate. This potassium chlorate will decompose in the presence of manganese 4 oxide. So everything must be written in word. Manganese 4 oxide. What will be the product? This arrow indicates the product. It is potassium chloride, then plus oxygen gas. So we are getting potassium chloride plus oxygen gas. That is the product which is getting out during the reaction in the boiling tube. Now we have collected the oxygen gas we want. What is the method for collecting this gas? The gas is collected by downward downward displacement of water. Downward displacement of water. The question is, why do we collect the gas by downward displacement of water? The reason is because oxygen is slightly soluble in water. Why? The question is, why do we collect the gas by downward displacement of water? It is because oxygen gas is slightly, the word slightly means in a very minimal amount, slightly soluble in water. Soluble in water. It means the gas dissolves in water in a very, very, very small amount. That is the meaning of the word is slightly soluble in water. So you'll be given a question that explains why oxygen gas is collected by downward displacement of water. The answer is because the gas is slightly soluble in water. Now we have known the method for collection. We have now, okay, with the diagram setup, we have seen the reaction taking place between potassium chlorate and manganese 4 oxide, between hydrogen peroxide and manganese 4 oxide. Let us see what the chemical test for this gas collected oxygen. So we are going to see how do we test the gas. Now we have collected the gas in the laboratory. How can we identify that this is oxygen gas? We call a chemical test. Oxygen gas relights a glowing sprint. Oxygen gas relights a glowing sprint. In another language, it rekindles a glowing sprint. So test, we call it chemical test of oxygen. Chemical test. Oxygen gas relights a glowing sprint or rekindles a glowing sprint. So this is a chemical test for a gas collected in the lab. So you may meet a question that asking you, how do we differentiate ordinary air from oxygen gas? When you talk about ordinary air, we talk about oxygen in the atmosphere. That is ordinary air. So ordinary air does not rekindle a glowing sprint, does not relight a glowing sprint, but the oxygen gas relights a glowing sprint. So once you meet a question that requires you to explain the differences between ordinary air and the oxygen gas, the answer will be oxygen gas relights a glowing sprint as its chemical test, but ordinary air does not relight a glowing sprint. After knowing the chemical test of oxygen, let's go and see the chemical and physical properties of oxygen. Now we are starting with the physical properties of oxygen. Physical properties of oxygen. Physical properties. Physical properties of oxygen gas. Physical properties of oxygen gas. Number one, oxygen is odorless, colorless, and tasteless, meaning oxygen has got no color, oxygen has got no smell, oxygen is also tasteless. It has got no any taste. Number two, it is about the boiling point of oxygen. Oxygen boils at negative, oxygen boils at negative 218, that is 183, degrees centigrade. It boils at negative 183 degrees centigrade. And it freezes at negative 218 degrees centigrade. So the boiling point is negative 183. The freezing point of oxygen is negative 218 degrees centigrade. And also oxygen is slightly soluble in water. Is slightly soluble in water. Slightly soluble in water. It means it dissolves in water in a very small amount. It dissolves in water in a very small amount. After knowing the physical properties of oxygen, the next is about the chemical properties of oxygen. Here you have to pay more attention because some they involve the reaction. Therefore, let's see the chemical properties. How can you identify oxygen chemically? That is the chemical properties. Chemical properties of oxygen gas. Chemical properties. Number one, oxygen supports combustion. Oxygen supports combustion. So oxygen does not burn, but it supports combustion. So chemical properties number one, it supports combustion. It supports combustion. Oxygen supports combustion. Number two, oxygen is a good oxidizing agent. Oxygen is a good oxidizing agent. Good oxidizing agent. Oxidizing agent. You know, in hydrogen, we are going to discuss about oxidizing agent and reducing agent. We are going to see why do we say oxygen is a good oxidizing agent. But number three, oxygen react with metal. And once they react with metal, they form metal oxide. Oxygen react with metal to form metal oxide, or in the other language, oxygen react with metal to form basic oxide. So, oxygen react with metal to form metal oxide. Metal oxide. This metal oxide is basic in nature, so it is called the basic oxide. For instance, how does it form a metal oxide or basic oxide? Consider the following reaction. Example, sodium. Sodium reacts with the oxygen. Sodium is a metal, so it reacts with oxygen and they produce sodium oxide. Sodium oxide. Potassium reacts with oxygen. Potassium react with the oxygen gas and then they produce potassium oxide. Potassium oxide. So this is basic in nature. It is basic in nature, that is why it is called the basic oxide. That is another chemical properties. It reacts with metal to produce basic oxide, or it reacts with metal to form metallic oxide. Another chemical properties, the last one, it is the reaction between oxygen and non-metal. The reaction between oxygen and the non-metal. So number four, oxygen react with non-metal. React with non-metals to form acidic oxide. They form acidic oxide or non-metallic oxide. For example, carbon react with the oxygen, and once they react, they produce carbon dioxide. Carbon dioxide. This is acidic oxide or non-metallic oxide. Example, sulfur react with the oxygen. Sulfur is also a non-metal to produce sulfur dioxide. So these are the chemical tests of oxygen. Number one, it reacts with the metal to form metallic oxide. Number two, it reacts with non-metal to form non-metallic oxide. Number three, it supports combustion. And number four, it is a very good oxidizing agent. So these are the chemical and the physical properties of oxygen. After knowing the physical and the chemical properties, the last thing that you need to know about oxygen is the uses of oxygen. Why do we need oxygen? We need oxygen in order for the following reason, that is, uses of oxygen. Number one, oxygen is used by mountain climbers. It is used by mountain climbers. It is used by mountain climbers. Those people who climb the mountain to the top of the mountain. That is, they need oxygen in order for them to survive. But also, number two, it is used by divers. Divers who goes deep down the sea. It is used by divers who goes deep down the sea. They need oxygen in order to go deep down the sea so that they can keep on surviving. And also, oxygen is used in respiration process. Respiration process. Oxygen is used in respiration process. We know that we are inhaling oxygen. So we need oxygen during the respiration process. But also oxygen is used in hospitals. It is used in hospitals. Why do we need oxygen in the hospital? First of all, it is used in the incubators. Incubators to assist premature babies. It is used in the incubators to assist the breathing of premature babies, but also it is used by people who are in ICU, intensive care unit. It is used by people under the intensive care unit. So these are the uses of oxygen. If someone will ask you, mention the uses of oxygen. Number one, it is used by divers. It is used by mountain climbers. It is used in the hospital, in the incubators for premature babies, and also in the intensive care unit. We call it ICU. But also it is used for welding process. It is also used for welding purpose. Welding. That is, it assists in the melting of metals. It is used in welding. There is a flame known as oxyhydrogen flame. This oxyhydrogen flame, it is a flame used during the melting of metals. So these are the uses of oxygen gas. These are the uses of oxygen gas. I hope we had a good discussion. I hope now we know what is oxygen. We know how we can prepare oxygen in the lab. We know the chemical properties of oxygen. We know the physical properties of oxygen. We know the uses of oxygen. But also, we know how to differentiate oxygen from ordinary air. Thanks very much for listening. Goodbye.